Now let's introduce a popular container management and orchestration solution called Kubernetes. Let's say your organization has really embraced the idea of containers. Because containers are so lean, your coworkers are creating them in numbers far exceeding the counts of virtual machines you used to have. And the applications running in them need to communicate over the network. But you don't have a network fabric that lets containers find each other. You need help. How can you manage your container infrastructure better? Kubernetes is an open source platform that helps you orchestrate and manage your container infrastructure on premises or in the cloud. So what is Kubernetes? It's a container-centric management environment. Google originated it and then donated it to the open source community. Now it's a project of the vendor-neutral, cloud-native computing foundation. It automates the deployment, scaling, load balancing, logging, monitoring, and other management features of containerized applications. These are the features that are characteristic of a typical platform as service solutions. Kubernetes also facilitates the features of an infrastructure as a service, such as allowing a wide range of user preferences and configuration flexibility. Kubernetes supports declarative configurations. When you administer your infrastructure declaratively, you describe the desired state you want to achieve instead of issuing a series of commands to achieve that desired state. Kubernetes' job is to make the deployed system conform to your desired state and then keep it there in spite of failures. Declarative configuration saves you work. Because the system's desired state is always documented, it also reduces the risk of error. Kubernetes also allows imperative configuration, in which you issue commands to change the system's state. But administering Kubernetes at scale imperatively will be a big missed opportunity. One of the primary strengths of Kubernetes is its ability to automatically keep a system in a state that you declare. Experienced Kubernetes administrators use imperative configuration only for quick temporary fixes and as a tool in building a declarative configuration. Now that you know what Kubernetes is, let's talk about some of its features. Kubernetes supports different workload types. It supports stateless applications, such as an Nginx or Apache web server, and stateful applications, where user and session data can be stored persistently. It also supports batch jobs and daemon tasks. Kubernetes can automatically scale in and out containerized applications based on resource utilization. You can specify resource request levels and resource limits for your workloads, and Kubernetes will obey them. These resource controls let Kubernetes improve overall workload performance within a cluster. Developers extend Kubernetes through a rich ecosystem of plugins and add-ons. For example, there's a lot of creativity going on currently with Kubernetes custom resource definitions, which bring the Kubernetes declarative management model to an amazing variety of other things that need to be managed. The primary focus of this specialization, though, is architecting with Kubernetes, because it's provided as a service by Google Cloud, so extending Kubernetes is not within our scope. Because it's open source, Kubernetes also supports workload portability across on-premises or multiple cloud service providers such as GCP and others. This allows Kubernetes to be deployed anywhere. You can move Kubernetes workloads freely without vendor lock-in.